In this video, I am going to show you how to find the terminal point of a vector given the components of the vector and the initial point. So this is a common exercise in calculus books. Like late calculus 2, early calculus 3. These are the kinds of questions you might have to answer. Okay, so you're given something of the following form. You're given a vector v, and it's got an x component and a y component. So those usually are written as, and I will color code. So the x component is the red 2, and let's say the y component is the bluish 2. Okay? Alright, so once you have this, then you're also told that there's some point I will call I, and let's say that point is, for the sake of simplicity, 3, 4. Okay? So this is the initial point. These are the components of a vector, and now you've got to get to the terminal point using this information. So the first step, to be sure we know what we are doing, visualizing, draw an XY coordinate system. That is what you should be doing anyway all the time, just to refresh and keep things, current. So this is your x-axis, your y-axis. They cross at 90 degrees. Scale things. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There we are. So with this in place, the next step is the following. Mark your initial points. So that's got an x of 3 and a y of 4. So you go 3 to the right, and then up 4. And let's see, 3 and then 4. So there's our initial point. Mark it. Okay, this is the 3 and this is the 4. This is 3, up 4. And now follow the components of the vector from this point to reach the terminal point. So in other words, this is what you do. You will go 2 to the right, 1, 2. Okay, this is the x component of the vector. And then go 2 straight up. All right. Then go 2 straight up. 1, 2. So this is the y component of the vector, you see? And then read off the coordinates of that point. So what are they here? Let's take a look. You've got your, it looks like 5 for the x and 6 for the y. There we are. So just by following the components of the vector, you can reach the terminal point, you see? So you're beginning with 3, 4. You're going 2 to the right, 2 up, and it takes you to the point 5, 6. If you like, the terminal point can also, of course, be written simply now as you take the 3 from the initial point and you add to it the 2 from the components of the vector, okay? So that looks like this. Add to it simply the 2. And then take the 4 from initial point and add to it the green 2 over here, or the bluish 2 if you like. Depends on how you see it on the camera. So it looks like this. Okay. So the terminal point is then simply 5, 6. So this is the algebraic approach. All you're doing is adding little line segments together. And then this is the picture-based approach. So you're some dude over here, right, sitting on a point, right, running over here and then climbing up, and you're stopping right here, and the coordinates of this point are 5, 6. You traveled from the point, initial point, you traveled 2 to the right and then 2 up. Now let's take a look at an example of this if you are given instead a terminal point and a vector in component form. So that's another common exercise in this context. So I'm going to take this away and replace it with a fresh sheet. And we'll color code All right, so say you're given the vector now that looks like this, right? This is your v, and it's got some components. Say this component is, for the sake of simplicity, 3, and the y component, let's make that fairly tame. We'll make that a 2. There we are. So those are the components of our vector. And say the terminal point is now given instead. Say the terminal point is 6 and 4. So this is the terminal point. These are the components of the vector. What we want to do is find I, the initial point. Okay, that's what we need to find. So how do we do this? Well, first, as always, begin by construct a little coordinate system for yourself. There we are. Keep it clean, neat, so it's easy to read what you need to read from the graph. Okay, there we are. Label things appropriately. So this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Mark the terminal point. The terminal point has coordinates 6, 4. So 6 to the right and then 4 up. So where does that put us? Let's see. That puts us right here. Okay, so those are the terminal point coordinates 6, 4. And now we had to reach this point by following these components. So now follow them backwards and take a look. Instead of 2 up now, you have to go back 2, right? So 1, 2 down, so to speak, and then instead of 3, to the right, you got to go 3 to the left. So 3 to the left. 1, 2, 3. And guess what? Here you've arrived at the initial point. And now, because we've drawn our picture very carefully, we can simply mark the point as 3, 2. So the initial point is 3, 2. That's it. Now, you want to be able to do this algebraically also, so if you want the initial point, simply do this. Take the terminal point x and subtract from it the component here, 3. So you have 6 minus 3, and then take the 4 from the terminal point and subtract from it the 2. Okay, so you're subtracting from the x and y coordinates of the terminal point the components of the vector. That's what I've done here, right? So all that remains now is 6 minus 3, which is 3, 4 minus 2, which of course is 2. So this algebraic step confirms the picture also, see? So this is how you find an initial point given a terminal point and a vector expressed in component form. Thank you for watching.